Welcome everyone to today's webinar on using DevOps for continuous deployment and delivery. Prashant's gonna walk you through the deployment solution he's developed at Altus, and which is implemented at a number of clients to automate deployments to their data platforms. So just briefly a bit about Altus. Altus is Australia and New Zealand's largest privately owned data analytics consultancy. Been around for 25 years. And we combine industry expertise with technical knowledge to deliver tangible outcomes for our clients. Let's just on to the next slide, Prashant, a bit about the services that we offer. So from left to right, we offer advisory, delivery, and managed services to our clients. So data strategy, type work, maturity assessments, etc. in the advisory space. And we drop down into delivery and implementation of solutions for our clients. And finally, we support the solutions as well that we deliver to our clients once they're productionized. We offer also a range of frameworks to speed up the implementation phases, such as our data load accelerator, which is a metadata-driven framework that allows customers to quickly ingest and use data into their data warehouse. And the deployment solution Prashant's going to talk us through today complements the DLA quite well by allowing us to automate the deployment of the code and configuration that's deployed as part of that framework. So before Prashant gets going, just wanted to point out there is a Q&A box in the Zoom window. You can ask questions as we go along, and we're going to review and answer all of the questions at the end of the presentation. So over to you, Prashant.
Thank you, Fede. Welcome everyone for this presentation, and we have good numbers for today's event. Today we're going to talk about continuous deployment and delivery, how it's going to complement our lifestyle as well as we go forward with a lot of releases and deployments. Now we want to enjoy this deployment, not be stressed about deploying things into production. We can make sure that our life gets easier with the continuous deployment by using an automated pipeline. And over the period of time, our trust will be built on this continuous deployment pipelines as well. So for the introduction, what we're going to talk about is the application deployment versus the SQL deployment. So in an application deployment, what happens is usually if it's a Java-based application, you build a package, you stop the service, install the package, and then start the service. This is an oversimplified version of what an application deployment looks. But we also have to look at your load balancer, route the traffic, bring up the other nodes. If you have a Docker, all the sort of things, you have many things that are in the application deployment. When it comes to SQL deployment, it's pretty straightforward. What we are doing is creating a database object, which could be a schema, sequence, functions, views, and tables. And then once the deployment is complete, we want to run our staging jobs for the staging to be loaded, and then our data model layers to build our facts and dimension. So they're basically two steps into it. So if the application developers can automate all of these different stages in a pipeline, I'm pretty sure we could also achieve this, and we only have two steps. So let's talk about manual deployment versus automated deployment. So what happens in a normal environment in most of the SQL developer teams is, so we copy, paste, and execute the scripts across multiple environments. Everything was left to the one person deploying the code. So the person who's deploying the code is always stressed because he has to work overtime, or if there are any failures and if the developer is not around, he needs to look into it, what has failed. So this person is definitely not enjoying his chips at the end of the day. So it's a bit hard for leaving it to one person or to the BAU team when you're a project team handing over the deployment to others. And the deployment issues are identified just before go live. As I said, as you deploy, if there is a semicolon missing, if there's something missing, or if it's not in the right order, so it becomes harder for them. And they don't have the time to watch the Bachelorette show, which is the new season which is coming up. And it is also time consuming. So you have to take one resource out of your BAU to do the deployment in the production. But what is also happening is you also have the developers spending considerable amount of time deploying this code into dev, test, UAT, pre-prod. So that's a big time window we are talking about. And when it comes to automated deployment, we promise it's a one-click deployment, but it's not always the case, but we can make it as an one-click deployment. So this person, by clicking on the button, let the pipeline do the work, and he can eat his chips and watch Netflix, or whatever your favorite show is on Netflix. And then instead of putting that responsibility to the one team or the one person, what we are doing is shifting it to the left so that everybody is responsible for the continuous deployment into non-production environment. So what we are doing is, since you're using the same pipeline to deploy it into your dev, test, UAT, and pre-prod, you have the chance of identifying any deployment issues beforehand rather than waiting till pre-prod and then finding all these issues. And the other thing is identifying deployment issues early on. And then this also opens new doors for automated testing. Once you start going down this path of continuous deployment, you could start thinking of what automated testing tools do I have for doing continuous testing so that it improves the your code quality continuously. And you're also getting a continuous feedback from the system, like this release went on with this many issues, and this was fixed, and how many of that your testing framework has picked as well. The other added benefit to this is frequent releases. We always are worried about deploying things into production, not breaking things. But we also have to understand we are in a data world, that we are not working with live system always. And when something goes wrong, it is not catastrophic as it is if somebody trying to take Amazon down during Christmas. Think about the impact on that one. So we are pretty safe on that side as well. So we can also plan for frequent releases as you build confidence on your deployment process. Let's moving on to the next slide. What tools do we have? For the purpose of this meeting, we are going to talk about Flyway, but just to give you a comparison, we have two different open source tools that are available, which is Flyway and Liquibase, and there are many more. I'm not going to get into that today because we don't have the time. For our Altus implementation, what we have done is we have done both the Flyway and the Liquibase version of the implementation, depending on what the client wants and what their requirement is. So they both are open source. The community edition is open source. But if you are a financial institution or or any other critical systems that you're dealing with, and if you want a support, then you can go for the commercial licensing. And not all features are free in both Flyway and Liquibase. Rollback and cherry picking are in commercial edition in Flyway. What I mean by cherry picking is you have like 10 different change objects, and then you want to pick only one particular instant of your change and then apply it into production. Those sort of features are not available readily or not in open source in Flyway. Rollback is readily available in Liquibase, and rollback is something you can always do it manually when things go wrong. And we recommend always going for a forward fix. And then so in terms of the key difference between Flyway and Liquibase is how your scripts are coded. If you're having a simple data mart and data warehouse, and if you are very comfortable with SQL, and if you have a defined path where your data warehouse is going to be in 10 years, like for example, hey, I'm going to stick to my Snowflake for the next 10 years, then I think Flyway would be the right option, because you write pretty much in SQL everything. But if you say, hey, I'm not sure if in 5 years down the track where my data warehouse is going to be, I might move to a different technology. And then that's where, instead of writing all your scripts in just SQL, you can write it also in XML, JSON, and YAML. So in the next slide, I'll show you how this is different. So the Flyway works primarily based on naming. So as long as developers stick to the guidelines of the Flyway naming, we know that it's going to work. And for Liquibase, it works based on change set. So they both support a wide variety of databases. And so in terms of compatibility and support, you get an extensive support on a number of databases. Liquibase also support NoSQL DBs, Mongo, and Flyway is working towards supporting them as well. So here is a quick structure that we have created for our Flyway implementation. So on the left-hand side, you would see the project folders where you have like a pre-deploy folder where you have different migration scripts, the after migrate, before migrate, and RR and V1. So we need to pay attention to this RR and the V1. So Flyway has got this two different migration scripts. Basically, one is called as a version migration, and the other one is called as a repeatable migration. So repeatable migration is a script. Every time when there's a change, it will be executed automatically against your database. So, and then in terms of writing the SQL scripts, it's pretty much the same like what we normally do. It's just a normal SQL. You write it as such you are. But have a look at it here. Here, this is coded as dev. But what if I want to have the same script and deploy it into multiple databases? So Flyway does have an option for it. You can use a placeholder for it and then parameterize this one so that at the runtime, whatever it sees here will be replaced by the actual DB. So that's something you have to educate your developers if you are going down this path. And here, what we have is a quick view of how Flyway changelog is captured. So you will see the version that it is as install and the description. That's pretty much the file name in this case, and then the type, the script, and the checksum. So I will get to this checksum in a bit once I explain how Liquibase is set up. So on the Liquibase, what we have is it works based on a change set tag. So here I have a change set tag, and the author is Prashant, and this is the change set tag, and then run on change is false. This is equivalent to repeatable migration, which we looked in the Flyway side. So if you set it to run on change equal to false, it's not gonna, if there is something that's been changed in the script, you have added a column, so it's not gonna run. So if you set it to true, every time it detects a change, it's gonna run. And this is how the database changelog works. You have to specify where you are, what are the scripts that you want to be part of this changelogs, and then you can also specify at the root level rather than just specifying the SQL. And this is how Liquibase tracks its changelog. This is all. Every time when a deployment is done, it will update a table within the Snowflake or in Redshift or any databases to capture this information. Here you have the file name, which was deployed, which is the, have a look at it here. It has the whole file name folder structure. The reason why is Flyway is basically working on the file name, so you cannot have duplicate file names. But on a Liquibase, you can have duplicates, and depending on the folder, it's going to identify as the different script. And the order of execution is one, it's executed, and MD5. So basically what they are doing is both Flyway, what they are doing is Flyway and Liquibase, they create an hash for your script, for your SQL script, and then they persist it in the DB. And every time when you change something on the script, the signature of the hash changes. So what it is doing is Flyway and Liquibase is comparing it against with the MD5 sum here or the checksum on the Flyway instance. And then, hey, I have detected a change. I'm going to run it against the DB. That's what it is doing. And this is all done basically using a JDBC connection underneath. So, if you want, you can go full on and write a Java code to do all of this. But I think we should take advantage of the Liquibase or the Flyway open source technologies. So for this particular client, we worked with, we did have to choose Flyway. Why? Because they didn't want to spend a lot of time on adding these tags into this scripts for Liquibase. So we had a minimal change to the SQL script and no impact to the team, how they were working on. And then the renaming the files were sufficient for the migration. That's all we had to do, apart from the one thing where we have to parameterize the DB and we have to, and we pretty much could do it in a day or two using a Python code to rename all the files. So when it comes to functionality, both Liquibase and Flyway are identical, but they differ on how it is implemented. One is using the file names, the other one is using a change set. They both support a wide range of databases. You would not go wrong with either of them. So what is a Flyway changelog? This is something I touched upon before. Changelog is how Flyway tracks changes on our script and identify what needs to be deployed. So Flyway creates a checksum of SQL script file and tracks it against the change log. Every time when the file is modified, the checksum changes. When a change is detected, it's going to run the script against an environment. So as I said before, there are two main migration scripts that you can write in Flyway. One is called the version script. You are not allowed to alter the version script once it is deployed. So here in this example, you could see that v3 is the create table script and v3.1 is a create table hello world.sql. So if you want any changes to the existing table, what you do is you create an additional version of it and then use it. And for I would stick to this as a golden rule. If you could say any create table or create sequences, create tables and sequence and functions, you could pretty much use a version script. That's what we used. And any views or procedures can be a repeatable script because it doesn't matter how many times you deploy it, it's not going to change the outcome of the view. So, and then we move on to the next slide. So, what it takes to implement an fully automated deployment pipeline. So there are a number of components that we need to be aware and we need to have some knowledge on it. And most of them you could Google it or, or watch some video online and you could pretty much figure it out. But a deep understanding of some elements are required within Flyway, what you want to do, how you want to implement it, what are the challenges that you're going to have, because we have done it multiple times, we are quite comfortable with all the challenges that we might encounter. So the first one is the Azure DevOps. So you basically need something to orchestrate all these deployments, right? And the Azure DevOps, you can use it. And then the deployment has to run on a specific mission. Back in the days, you could spin up a local VM on your computer, use that as an agent, and then run it. You still can do it. Even with Microsoft self-hosted agent, you can actually, even before going into production, all your team could test this whole automated pipeline even from their laptop. So that's possible. And I mean, this is where application developers had a upper hand before, where they could, instead of doing things into the actual database, what they would do is spin up an in-memory DB, test their application, and then do it. So we could pretty much do it now, but not with an in-memory DB, but we're going to do it against the database. And then the next thing is we should have a good understanding of Git workflow. Basically, how do you want to tag your branches to the different branches? For example, how do you want to tag your environments to different branches? In this case, what we had is a pretty simple Git workflow, which is a feature dev, which we all had our own dev branches. And then what we did is this is a branch you would deploy into the development environments. We had some level of leniency towards the dev environment because we don't want to restrict them too much, saying, hey, you got to use it pipeline to do it in dev, because multiple people are deploying into dev. So we did have some leniency on it. Say, okay, dev is your play area, do whatever you want to do. The moment you hit the sit, so we said you got to do a merge into master, and then somebody is going to peer review it and then approve it. Once it is approved, it would be automatically deployed into the test. So now we know that our test environment is pretty stable enough. So the sit testing is stable enough. Now we want to move to the UAT. And then again, it will go into the release branch, and then that's what gets deployed into UAT and into the pre-prod. This is our stable branch release. And then you could have multiple releases into this branch if there are multiple developers working as part of the release. And then finally, we don't deploy a production branch into production. What we do is we deploy the release branch into the production database. And then once, if it is only successful, once if we had a successful release into production, we merge into production. At any given point in time, production is the most stable branch, and you could take that code and put it into any environment and have faith in it that it's gonna work fine. So, and let's say if there are any bug fixes, so what we do is you branch off from the production branch, create a release branch or a bug fix branch out of it, and then follow the same life cycle. So we make sure that everything gets deployed into every environment, with some exemption if there is a hot fix that has to go into tomorrow. Those sort of things are usually uh, approved. And then the other thing is we also had Maven for managing our projects and dependency, because we didn't want to go to the IT guys, say, hey, there's a new version of Flyway, can you put it in this mission? There's a new version of JDBC driver, can you put it in this mission? Those sort of things. So we pretty much used a Maven for dependency management. And if you're really worried about security, you don't have to use the M2. You can have your own Nexus within one of those self-hosted agents, those sort of things. And so you basically, when there's a new version, you basically update the version number in your POM file, and then it will get automatically, the deployment process will use a new artifact. And on the agents, when you're using Maven and Flyway, you want to use Java open source. Make sure you get the Java open source, not the Oracle version of it. And you also have to have the Maven package. If you want to make it really fancy, go ahead and use a Docker image that you can put it onto the on the self-hosted agent, spin the component, destroy the component, just move on. Yeah, that's a fancy version. We do have that version as well. And then finally, once the deployment is all done, now we want to run our ADF pipelines to populate the staging, and then populate the staging, and then do a post, and then trigger the mark. In one of our instances, what we had is we would do the deployments for stage-related things, trigger the deployment, the ADF pipeline will run successfully, and then we will deploy our facts and dimension. Then we will trigger the ADF pipeline. So we could orchestrate different stages on how we want, and yeah, pretty much we got this right, I think. So this is a sample architecture that we had. This is not a detailed architecture. This is at a high level what we did. As you can see, this is all in Azure DevOps. So you have the Snowflake repo, and then you have a deployment pipeline. We had 3 different pipelines in this case, one for dev, one for test, one for prod. And we use the same test pipeline for our pre-prod as well. And then you have this mission, which is the trusted mission, which we used for deploying our changes. And then from there, what it does is it connects to the Snowflake environments. First, it does an OAuth call. The OAuth is retrieved from the Azure, and then it uses that OAuth and then deploys into, and then connects to the Snowflake and then deploys into things. So we also had different approvals in place to make sure that nobody's accidentally triggering deployments into production. And then it also uses a secured protocol TLS 443. So these are things that will come the moment you say automated deployment, your security guy is going to come and ask, hey, is this secured enough? Is anywhere in here you're hard coding your password? Are you printing something in your logs? We are also using Java, so make sure that you are using the right version of Log4j, because there was a vulnerability in the Log4j in the past. So those sort of things, you should be constantly aware of things, because you also want to keep this pipeline healthy and continuously running, not just do it as a demo for 2 days and then forget it. So now keep bringing this let's up chips joke. I don't know if you get it. So usually when you're doing a deployment, you're pretty stressed. So now what I want to do is, what everybody can do is eat some chips, have some beer, and click a button and let the pipeline do the job, and have a good Christmas next year if you manage to get the pipeline. It doesn't take that long as well. So let's get into a live demo. So here we have a live demo of our for flyway migration. So as you can see, this is all structured in the way we want to deploy things. First is a pre-deploy, and then we had something related to DLA, our data load accelerator, and then any stored procs, tables, views, and post-deploy. So this is a demo, so we don't have all the codes here, but we do run it extensively. In this one, you could see there's an after migrate and before migrate. These are called pre-hooks. I think callbacks. This gets executed every time, irrespective of what happens within the other scripts. This is when you want to do some cleanup for your testing or do something. Hey, feel free to use this after and before migrate. And then you have this repeatable migration script, which is in this case, I'm saying the hello print is usually associated with programming languages, but hey, we can use it as well. So SQL developers can't use hello world. So that's the first script that it's going to do. And then you can see there's a create and replace schema. I would strongly advise not to use a replace in your version scripts because you don't want it accidentally to replacing something which you don't want. So create and replace view is fine, but not sequence. But it might be different for each use case. And then you have a create and replace sequence, and then you have a create table, which is just creating a simple table for us for our demo. And then what we have now is another version 3.1, which I've marked it as X instead of V. Anything that you can define what is your version prefix and what is your repeatable migration prefix. So on this instance, what you have is a V, which I've set as my version prefix, and RR as my repeatable migration script. And all of this can be listed here in our POM file. And yeah, this is configurable how you want to do it. So let me click on execute. Before that, I'll truncate all these things. So now we don't have anything. So let me hit run. So as you could see, what it is doing is it is doing a Maven build. So as part of this build, we have different stages. And for now, we are just going to do a pre-deploy step. It's building it. So for now, what I've done is I've run an info, and what it is basically saying is what is pending for migration. So all of this at this point is pending, and you can see the X 3.1 is not picked. So now what I'll do is I'll do the actual deployment now. So there are Flyway has got a couple of goals. One is info, the other one is called migrate, and then repair. And then there's another one, clean, which I would advise not to use at any point because it wipes out everything. So stay away from using it. You can use a delete script to delete something if you want. So now it's starting again. So once you use OAuth, you don't have to have a browser authentication. So it will pretty much go away. So output SQL developers can print hello world. That's good. So what it is doing is it is applying the migration in this order, version 1, version 2, and then version 3. It's creating a table. And then it is doing the RR script, which is inserting this value. By the way, you can also ask your Snowflake guys to turn off this browser authentication every single time. So the build is success. So what happened now is you could see, if I show you the changelog table, so it has installed version 1, version 2, version 3, and then they insert hello world. So now what I'm going to do is, okay, so it says SQL developers cannot use hello world, right? Now, what I'm going to do is I'm going to change the RR script to say SQL developers can use hello world. Now, what I'm going to do is rename the script to say E3.1 refactor. So it's going to add a column status Boolean for this example. So as you can see, it has only 2 columns. So now let's run it again. You can also baseline your migration. It will just create a checksum for all your existing scripts and not redeploy it. Those sort of things are all achievable. And but now do you see it only picked up the 3.1 version? And whatever scripts that were already executed wasn't executed because it didn't, those are all version scripts and no change was made to those ones. And if you could see, there are only 2 things that it is executing, which is the 3.1 and the on the RR script where I changed what's in here. So for all intents and purposes, I'll run this query in a separate one now. So here, earlier it says can't use hello world. Now it says can use hello world. And also, let me quickly show you this one. So it has inserted the new 3.1, altered the table. And here you can also see it has the new status column. So this is how you make all your changes, and you could use Git to track all your history within the files as well. So it is pretty much doing the developer way of doing things. And finally, how does it all look in our Azure DevOps? So this is how it looks in our Azure DevOps, where you can say which branch you want to deploy and what stages do you want to deploy and what is the flyway command that you're running. So let's say if there is a failure and you want to repair it, you can repair it using the flyway command repair. What it basically does is removes an entry, the failed entry from the flyway changelog table, and then select the database that you want to migrate, dev test prod, and these are the different stages, what it's doing. So this is how we have implemented automated deployments. And you can also start, once you do this, you can also start looking into unit testing. So unit testing within SQL developers has always been a bit challenging, or, creating a test suite of test cases. We couldn't use Selenium. We couldn't use, there are a few things, but you could start integrating as part of your pipeline. So you are getting a constant feedback from the system at every stage of your development lifecycle, not just in the production going and going kaboom. Yeah. And yeah, that's pretty much the demo. And then, so finally, what challenges did we have? So to build this capability, the developers, as an SQL developers, it's also good for us to upskill on Java, Maven. If you can also try a version of Python version of it, and so we basically have to have some level of knowledge on all these things, and I think it is pretty much achievable by everyone. And be prepared to meet the security folks. They don't like you eating chips because they don't want you to click the button and deploy things. So you got to be prepared and make sure that your architecture is secure enough for so that nobody can misuse it. And then you need to also have a good knowledge on Azure DevOps and how stage works. And finally, YAML files can be messy because to create the DevOps pipeline, you need to set the stages, specify some service connection, specify which machine it's going to run. All those things has to be done in YAML. but it can be manageable. It's not something, it's hard, it's easy to learn as well. And so your team might have been working in a certain way, copying paste, comfortable, and missing things during production, and that bites back. So you got to be a bit more how you want to make this transition. So the one way you could do is supporting when you develop this pipeline, you need to support it for at least for 10 runs to give them the confidence that they are understanding, and also have frequent KT sessions, and have lots of information on the Confluence, links to the external website for Flyaway and things like that. You can educate your team basically on all of these things. So, yep. And let's go on to questions.
Sure. That was a good overview of the deployment process and some of the different tool options, and architecture for how the deployment process was going to work, and a nice example. And while it only involved a few scripts, that basic example can be expanded to cover the different layers of a data warehouse, for example. And if there are no questions, then we'll leave it there and say thank you very much. Oh, nothing's come through. Easy. So we'll wrap it up there. Thanks everybody for attending, and thank you, Prashant, for
Thanks everyone. Bye-bye. Yeah.